Welcome to Academy. In this video, I calculated the solutions to our quartic polynomial 16 cos power 4x minus 16 cos square x plus 1 equal to 0, and I mentioned that the solution is x equals 1 divided by 12 multiplied by 6 pi n plus or minus pi, where n is set of all integers. I mentioned the solution, but I did not work out the solution. And today in this video, I'm going to give you a method to work out the solution. And for that, I'm going to use the classic graphical method of solving an equation. For the starters, what is a graphical method of solving an equation? Let's suppose that I have a simple trigonometric equation, that is cos x equals k, where x is in radians and k is in the closed interval -1 to +1. In the graphical method, you decompose this cos x equal to k into two equations, that is y equals cos x and y equals k, and draw the graphs of these two equations on the Cartesian coordinate plane. Let me explain. This is the Cartesian coordinate plane and this is y equals cos x, that is the classic cos curve, and this is the straight line, that is y equals k. Y equals k is a straight line parallel to x-axis. The line y equals k intersects the cos curve at different points. Pick the x coordinates of these intersects, and there I have all the solutions for cos x equals k. And remember, trigonometric functions are multivalued functions. Therefore, there are infinite solutions for the equation cos x equals k. But how to identify the entire set of solutions? For that, let us return to the main theme. We have seen that this polynomial has 4 roots, and the 4 roots are: the first root is cos x equals half multiplied by square root of 2 plus square root of 3. This is the second root, that is cos x equals half multiplied by square root of 2 minus square root of 3. And this is the third root, that is cos x equals minus 1/2 multiplied by square root of 2 minus square root of 3. And this is the fourth root, that is cos x equals minus 1/2 multiplied by square root of 2 plus square root of 3. Let us start with the first root, that is cos x equals half multiplied by square root of 2 plus square root of 3. Solving this equation will give you x equals cos inverse of 1/2 square root of 2 plus square root of 3. Now, if you type this on a calculator, you will get the answer as 0.261799 and so on, which is exactly equal to pi by 12. But that's not the only solution. Remember, all trigonometric functions are multi-valued functions. There are infinite number of solutions to our equation cos x equals this number. And in order to write out all the infinite number of solutions, I'm going to use the graphical method. Let's turn our attention to the graph I have drawn on the whiteboard. Like I said before, we need two graphs. One is y equals cos x and the other one y equals 1/2 multiplied by square root of 2 plus square root of 3. Here is the y equals cos x curve. Then here is the line, straight line, which is y equals 1/2 multiplied by square root of 2 plus square root of 3. And this straight line intersects the cos curve in different points. And the corresponding x values are the solutions to the equation cos x equals this number. And the width of my whiteboard can hold only 6 such points. The question is there a method to write out the entire set of solutions across the entire domain of cos x, that is minus infinity to plus infinity? Is there a method? Yes, of course there is one. Remember the 6 basic trigonometric functions, that is cos, sine, tan, secant, cosecant and cot, have a periodicity of 2 pi, that is the values keep repeating every 2 pi radians. Keep this in mind as we continue. First, let me explain what is known as the principal values. The principal values are the solutions in the closed interval minus pi to plus pi, and the principal values of solutions for our equation cos x equals half multiplied by square root of 2 plus square root of 3 are plus or minus pi by 12, because plus or minus pi by 12 is lying between minus pi to plus pi. Therefore, these two are the principal value solutions to our equation, and simply add 2 pi n to the principal values to get the set of all solutions, where n is set of all integers. Therefore, the general solution to our equation cos x equals 1 half multiplied by square root of 2 plus square root of 3 is x equals plus or minus pi by 12 plus 2 pi n, comma, n belongs to set of all integers, which means n equals 0 plus or minus 1 plus or minus 2 plus or minus 3 and so on. Notice that the principal value corresponds to where n equals 0. Simple. Let us now apply the general solution for n equals 1 and minus 1. And the solutions are plus pi by 12 plus 2 pi, minus pi by 12 plus 2 pi, plus pi by 12 minus 2 pi, and minus pi by 12 minus 2 pi. Let's do the arithmetic. So the four numbers are 25 pi by 12, 23 pi by 12, minus 23 pi by 12, and minus 25 pi by 12. And here is 25 pi by 12, and here is the 23 pi by 12, and here is minus 23 pi by 12, and finally here it is minus 25 pi by 12. Hence, we have used a method to identify all the solution that is contained within the width of this whiteboard for our equation cos x equals 1 half multiplied by square root of 2 plus square root of 3. And we can apply n equals plus or minus 2, plus or minus 3, plus or minus 4, and so on, to get the entire set of solution from this general solution, which is x equals plus or minus 12, pi by 12 rather, which is the principal value, plus 2 pi n. Next, let's answer a few questions. Write the number of solutions to cos x equals 1 half multiplied by square root of 2 plus square root of 3 in the following intervals. Open interval minus 2 pi to 2 pi. Left open minus 23 pi by 12 to right closed 25 pi by 12. Closed interval 0 and 2 pi. Closed interval minus 23 pi by 12 and pi by 12. Closed intervals minus 25 pi by 12 and 25 pi by 12. The answers are 4, 4, 2, 3 and 6. You can use the same method to work out the entire set of solutions for the other three roots, that is equation number 2, 3 and 4, and can be written as follows. The solutions are, let's take the equation number 2. Cos x equals 1 half square root of 2 minus square root of 3. The general solution is x equals plus or minus 5 pi by 12 plus 2 pi n. The principal value solution is plus or minus 5 pi by 12, corresponding to n equals 0, right? Then let's take the equation number 3. Cos x equals minus 1 half multiplied by square root of 2 minus square root of 3. The general solution is x equals plus or minus 7 pi by 12 plus 2 pi n. Therefore, the principal value is plus or minus 7 pi by 12. And finally, let's come to equation number 4, which is cos x equals minus 1 half square root of 2 plus square root of 3. And the general solution is x equals plus or minus 11 pi by 12 plus 2 pi n, where plus or minus 11 pi by 12 is the principal value. If I combine all the solutions which I have written here for these 4 roots, we will have the general solutions to our trigonometric equation. 16 cos power 4x minus 16 cos square x plus 1 equals 0. Let me list them out. Okay, so the general solution for our polynomial are pi by 12, 5 pi by 12, 7 pi by 12, 11 pi by 12, 13 pi by 12, 17 pi by 12, 19 pi by 12, 23 pi by 12, 25 pi by 12, and so on. And on the negative side, it is minus pi by 12, minus 5 pi by 12, minus 7 pi by 12, minus 11 pi by 12, minus 13 pi by 12, minus 17 pi by 12, minus 19 pi by 12, minus 23 pi by 12, and minus 25 pi by 12, and so on. So the general solution can be written as, the general solution is so that is the general solution to the list of numbers which I have written here. I would urge you to take a piece of pen and paper and match this general solution to the list which I have written here to verify whether our general solution matches with this list or not. Before I finish, let us answer a typical Olympiad level or JEE level question. What is the total number of solutions to the polynomial 16 cos power 4x minus 16 cos square x plus 1 equals 0 in the open interval minus 2 pi to plus 2 pi? And the answer is right in front of you. Thanks for watching.